All right, so that we're on 3.4 on present value of an annuity and amortization. So let's look at some exercises. So we're supposed to find I, the rate per period, and N, the number of periods for each loan at the given rate, annual rate. So we have a monthly payment of $433, and they're made for 3 years to repay a loan at 10.8% compounded monthly. All right, so what is I going to be? Well, I is going to be your rate. Now that's as a decimal 0.108. It's compounded monthly, so we have to divide that by 12. And if we take 0.18 times divided by 12, let's do that just on our calculator here. We get 0.009, 0.009 per month. Okay. Now, the other thing we're supposed to do is we're supposed to find n, and n is going to number your periods. Well, if we did it for 3 years, there's 12 months in a period, it's going to be 3 times 12, so that's going to give us 36 months. Okay, so that one wasn't too bad. Let's try another one. So here we're supposed to use either Formula 5 or 6, depending on how the problems work on the ones that are here, and solve. For this case, we're supposed to solve for n. So we get a present value, we've got the I, we've got the payment, and we're supposed to solve for n. So I think we're going to use PV equals PMT times the 1 minus 1 plus I to the negative n over I. So what do we plug in? Well, we plug in PV is 20,000. Payment is 500. Then we have 1 minus 1 plus 0.0175. That's to the negative n all over 0.0175. And I'm going to pull up the numeric calculator and a numeric solver on our calculator here online and see what we get here. So we'll do math, arrow up, numeric solver. So we have what, 20,000 is equal to. And now we have 500. Now the key to a lot of these problems are going to be, can you put the decimal or the parentheses in the right places? If you don't, then it's not going to work most of the time. So we'll have on the numerator 1 minus, and then we'll have 1 plus, and 0.0175, and then that's to the power negative x. We don't have an in option, so we just do that. And then in parentheses, so that has all that, and then divided by our 0.0175. And hopefully, if we hit graph and solve that, that gives us the answer. So n is going to be 69.3987. I don't think it said how many decimal places, so let's write them all down. So we had 69.3987. So if we are doing that, we have to go at least one higher, so that's going to be at least 70 months to be able to get that. So if we did only 69, we wouldn't get to the full value of 20,000. So we have to go up to the next higher month, which would give us 70 months. All right, so let's stop with that one and come back for some more.